Our next example will look a little bit trickier, but it's pretty much the same strategy we've been using the whole time. So make the bases the same. So here we have 1/6 to the power of x equals 36. I would reciprocate this 1 over 6 right away. So that becomes 6 to the power of negative 1 times x. And our common base would be 6, so 36 is actually 6 squared. So therefore we have negative x equals 2, and we'll multiply both sides by negative 1, so we get x equals negative 2. Again, looks way worse than it really is. Our second question, so now we've got fractions on both sides, but we can still find a common base. So this right here, maybe it's easier to start on the right side. 5 squared and 2 squared. So they can both be square rooted, both of these. So it's going to become 5 over 2, all squared. And then again in brackets 2x minus 5. So we have to ask ourselves, is it possible to make 125 to 5? Well, yeah, 5 cubed. And then what about 8 till 2? Yep, that's going to be 2 cubed. So this is going to be all 5 over 2 to the power of 3. And that's still got our x minus 2. Now that we have the same base, we can make these two exponents equal to each other. Again, I'll do the distributive property right away. So 3x minus 6 equals 4x minus 10. I'll subtract 3x off of each side, so I get x, and then I'll add 10 to both sides. So I get 4. So how are they going to trick you then? So these questions seem fairly short right now. So let's go into the next one and take a look at these fractions. So the left side fraction looks a little simpler to me. It's a little bit smaller. I can see that both of these can be square rooted. So that means I'm going to have 3 squared and 2 squared, or 3 over 2 all to the power of 2, x minus 4. And then on our right side, is it possible to make 8 become 2? Yeah, it is. 2 cubed. And 3 cubed is 27. So it'll be 2 over 3 cubed to the power of 2x. We got a problem though. The bases are very similar, and that we have 3 over 2 and 2 over 3, but one's a reciprocal of the other. So what we need to do is we need to reciprocate one of the bases. So I'm going to leave the left side the same. So I'll leave it as 3 over 2, and maybe I'll distribute this as 2x minus 8, and I'll reciprocate this base to make it become 3 over 2. Now to do that then, I need to make this 3 a negative 3. Okay, now we've got the same base. Now we can make the exponents equal to each other again. So we have 2x minus 8 equals negative 3 times 2x, which is negative 6x. I'll add 6x to both sides, so I get 8x, and then I'll add 8. Divide both sides by 8, you get x is equal to 1. Again, it's not terrible. It looks a lot worse than it really is. Our final question like this. So again, we got to look for a common base. This fraction looks a little bit simpler. So I know that 3 cubed is 27, and 2 cubed is 8. So I'm going to get 3 over 2, all cubed. And still have that negative 10x plus 1. So on the right side, then, is it possible to make 16 become 2? Yeah, 2 to the power of 4. And then 81 is 3 to the power of 4. So I end up with 2 over 3 to the power of 4 times 6x. Again, we've got that problem where the bases are close, but one is a reciprocation of the other. This time I'll reciprocate the left side, so it's going to become 3 over 2 to the power of negative 4 times 6x. I'll clean up the right side a little bit, so we get negative 30x plus 3. Now that we have the same base, we can actually make the exponents equal to each other. I will just do this multiplication right now. So you get negative 24x equals negative 30x plus 3. So I'll add 30x to both sides. So I get 6x is equal to 3. Divide both sides by 6, and I get 1/2. All right, example 3. So again, we want to solve this. What's a little bit different here is we have a fractional exponent this time. But again, it's really not a big deal. So we're still going to make the bases the same. So on my left side, I have 3. So I'm going to leave that as 3 to the power of 2x over 3. And on my right side, well, I'm going to turn that into 3 squared. So times x minus 4. And then now we can make these sides equal to each other. So, the exponents equal to each other. So we get 2x minus 8. I'm just going to multiply everything by 3 here. I think it'll make our life a little bit easier. So I get 6x and then minus 24. I'll subtract 6x from both sides, so I get negative 4x equals negative 24. And divide both sides by negative 4, so you get x is equal to 6. So not too bad. Let's look at the next one. So we have a base of 1 over 8 and a base of 4. Right away, I'm going to turn this into a reciprocated. So I'm going to turn it into a negative exponent. But then between 4 and 8, it's going to be 2 is going to be our common base here. So this will be 2 cubed. But because I am reciprocating it, it's going to be negative 3. And so I still have x over 9 minus 6. And that's equal to 2 to the power of 2. And then we still have that x over 2 minus 3. Now we can make the exponents the same. I will do the distribution right now. So this is going to become x over 3. And then we have plus 18 is equal to, well, these cancel out. So you're left with x and then minus 6. Yeah, I'm going to get rid of this fraction. I'm going to multiply everything by 3. So you get negative x plus 54 equals 3x minus 18, sorry. Then I'm going to add x to both sides. So I'm left with 4x on the right side. And I will add 18 to both sides. So I'm left with 72. I'll divide both sides by 4. And I get 18. So therefore, x is equal to 18.